Alright, so we've been talking a lot about solutions and how we make solutions and what can go in solutions. We haven't really talked about how concentrated they are. Scientists measure concentration in a variety of ways, but the main way we're going to focus on is molarity. So molarity is a measure of the concentration of a solution in moles per liter. So it's how many moles we have and how many liters of solution. So our formula for that is simply capital M molarity equals moles over volume in liters. It is actually a thing that must be in liters. We'll look at some problems where we have to convert. Alright, so let's look at our first problem. We want to find the molarity of a solution made by dissolving 0.335 moles of ammonium sulfate in 600 milliliters of solution. And so just like we've done in all the math problems in this class, we're going to pull out what we know. So we know that we've got some number of moles, in this case 0.335 moles. We've got our volume, which is 600 milliliters, but we just said it can't be in milliliters, it has to be in liters. So if you go back and think about it, you should remember that to go from milliliters to liters, we've got to move our decimal place 3 places to the left. So now we have 0.6 liters. Now, all we have to do, since we're looking for molarity, is plug it into our equation. So M is going to equal 0.335 moles over 0.6 liters. And we do our math, and we find that our molarity is equal to 0.56 molar. And yes, the capital M is both the variable and the unit. Just remember that capital M as a unit is also equal to moles over liter. And so that's going to be important if we ever need to use it in dimensional analysis. Alright, now try your guided practice on your own. Come back and check in with me when you're done. So the first guided practice problem. What is the molarity if 0.294 moles of sodium nitrate is dissolved in 0.4 liters of solution? So the nice thing is, this one's actually easier than our first one. We know that our moles equals 0.294 and our volume is 0.400 liters. It's already in liters. So we don't have to change anything. We're just going to plug it in. So molarity equals 0.294 moles over 0.400 liters. And so we're going to do our math. And our molarity is going to equal to 0.735 molar. Alright, so this next one is just a teeny bit trickier, but not that much. We want to find the concentration of 45 grams of ammonia in 0.75 liters of solution. So, we know our volume, definitely. We have our volume is equal to 0.75 liters. But this time around, we don't know our moles. What we do know is that we've got 45 grams of NH3. And if you think back to stoichiometry and a number of other things we've done in this class, if you've got mass and you need moles, you can do dimensional analysis and use our molar mass. And remember, our molar mass is that 1 mole equals the mass of everything added up from the periodic table, which in this case is going to be 14.01 plus 3 times 1.01, so 17.04 grams of ammonia make up 1 mole of ammonia. And so we do our math. Remember, we multiply everything on top, divide by what's underneath. And so we have 2.641 moles of ammonia. And that's in 0.75 liters, so molarity equals moles over liters. And so this is going to equal to 3.52 molar. Alright, so now you should be pretty comfortable with this. Really not that difficult. And do your next set of notes and then work on your practice.